Hello viewers, welcome to this next lecture on the MOOC course on mathematical portfolio theory. So, recall that in the previous two classes we focused ourselves on the utility, the expected utility and some of the properties in terms of risk attitude of investors, namely investors who are risk averse, who are risk loving and who are risk neutral, and we quantified them in terms of the utility as a function of the wealth level. And we specified the fact that u prime of w is going to be greater than 0 in all cases, and the u double prime of w, that is the second derivative of u, will change depending on the risk attitude of the particular investor. So, in today's class we will delve into a little more detail on this aspect, and we will introduce and discuss about two concepts, namely the absolute risk aversion and the relative risk aversion. So, accordingly we start this lecture with the concept of absolute risk aversion. Okay, so we begin by recalling that the risk averse investor would not be willing to get into a fair investment. Recall, we had looked at that investment where you could gain or lose 300 on an investment of 1000 as we had described earlier. Since, and the reason this happens is that it would lead to a decrease in the investor's utility. Okay, so for this you can refer to the previous lecture. Now, in order to avoid this risky investment, so what I am going to state is an interpretation of certainty equivalent. So, in this case the investor would be willing to give up an amount of cash called the risk premium denoted by phi. So, we have already introduced this notation phi, w and z tilde. Now, after giving up the risk premium, the investor would be indifferent to an investment with the random payoff z tilde and holding a certain amount of cash equal to the certainty equivalent. All right. So, just to elaborate this, so what I am saying is that we have already seen the example of the risk averse investors, and we have said that the risk averse investor would not be willing to get into this investment. Recall the particular example of the investment was that you start off with a wealth level W naught, and the probability with probability half, you could have a gain of z tilde, which in the example was 300, or we could have a loss of z tilde, again with a probability of half. So, the reason for avoiding this investment is that this would lead to the decrease in the utility of the investor. Now, in order to avoid this risky investment, the investor would be willing to give up an amount of cash called risk premium. So, that means that once the investor is willing to give up this risk premium, then when you look at the investment in a random pair of z tilde, that means this particular investment, or holding an amount of cash equivalent to certainty equivalent, then after giving up the risk premium, the investor would be indifferent to these two choices, namely the investment in the or this risky proposition and holding an amount of money same as the certainty equivalent. All right. So, now the utility of getting into the risky investment and holding a certain amount of cash which is equal to total wealth after the investment minus the risk premium. They are equal. So, this is just a manifestation of the previous term that I said that they will be indifferent to an investment in the random pair of z. So, this is equivalent to the statement that utility of getting into a risky investment, and the second point of certainty equivalent, this is equivalent to holding a certain amount of cash, and remember certain amount of equivalent will be given by total wealth minus risk premium, and they are equal. So, this statement is essentially just stating the preceding statement in a slightly different form. Okay. So, mathematically this would mean the following. So, you have the wealth W. So, you start off with the wealth level W, and then you get an additional amount of z tilde, which could be plus 300 or minus 300 if you consider a specific example, and you consider the utility of this. Now, since this is a random variable, so I have to calculate the expected utility of this, and this must be the same as the utility of W plus E z tilde with minus the risk premium phi W z tilde. So, this is the mathematical manifestation of my previous statement given here. Now, in a fair investment, what we will have? We will have E of z tilde is equal to 0. So, therefore, this line I can write, this expression can now be written as expected value of utility of W plus z tilde is going to be u of W. Now, this quantity is equal to 0. So, it is simply going to be the utility of W minus phi of W z tilde. We now take the Taylor series expansion of u of W plus z tilde, that is this component. So, therefore, u of W plus z tilde, this will be, so I take the Taylor series about z tilde. So, this will become u of W plus z tilde u prime of W plus 1 over twice factorial z tilde square u double prime of W plus terms involving z tilde cube and higher terms. So, this is the remainder term, and this is negligible, assuming z tilde is small. So, if I take expectation on both the sides, what will I get? I will get expected u of w plus z tilde. What is this going to be? Expected value of u w is going to be simply u of w, because it is the utility of the initial wealth level. So, it is u of w plus expected value of z tilde is equal to 0 from here. So, that means this term is going to be 0 and I have this remaining term here. So, this will simply become half u double prime of w into z tilde minus e of z tilde, which is 0 square. Alright. So, this is an approximate relation, and and this can be rewritten. So, here I just note that since e of z tilde is going to be equal to 0. So, this can now be written as u of w plus half u double prime of w into sigma z square, where the notation sigma z square stands for e of z tilde square, all right, which is the same as e of z tilde minus e z tilde square. All right. So, now we have taken this Taylor series expansion of the left hand side term. Now, what we do is that we now take the Taylor series expansion. So, again we take the Taylor series expansion of u of, so it is going to be Taylor series expansion of this term as a whole. So, it is going to be u of w minus phi w z tilde. So, I will take the Taylor series expansion of this. We get that u of w minus phi of w z tilde, this is going to be equal to u of w minus phi w z tilde u prime of w plus order of terms which are phi square w z tilde, and this is the remainder term. So, we are truncating here for simplicity up to this term. So, this is approximately equal to 0. So, just like we have done here. So, what is this going to give us? It is going to give us that u of w minus phi w z tilde is approximately u of w minus phi w z tilde u prime of w. Okay, now, let me call this relation 1 and I will call this relation 2. So, equating 1 and 2, what do we get? We get that u of w plus half u double prime of w sigma z square. I can equate that because the left hand sides are of both 1 and 2 are equal. So, the right hand side will be equal. So, u of w plus half u double prime of w sigma z square, this is going to be equal to u of w from equation 2 minus phi w z tilde u prime of w. So, therefore, from this relation we get phi of w z tilde is equal to, so these two terms will cancel out. So, it will become minus half sigma z square u double prime of w by u prime of w, and thus this. So, we can write that thus we can define the risk premium as, remember what is risk premium, phi w z tilde is minus half sigma z square u double prime of w over u prime of w. So, I have essentially got an expression for the risk premium in terms of the utility functions. So, this risk premium is called the Pratt So, this is a very classical concept. So, it is the Pratt-Arrow risk premium. Okay, so let us now look at an example. So, suppose that, so it is the same situation as the example considered in the previous lecture. So, we consider an investor with an initial wealth level of 1000 who is offered an investment with the probability, actually I should say with the possibility of gaining 200 or losing 200. That means, it can go up to 1200 or come down to 800, each with probability half. Okay, now, if I want to discuss the Pratt-Arrow risk premium, so I have to talk about the utility of the investor. So, we suppose that the investor has the log utility function so that is u of w is natural log of w, then the variance of the payoff what is the payoff, that is z tilde, is given by sigma z square. So, remember here E of z tilde which is half into 200 plus half into minus 200, this is equal to 0. So, sigma z square is going to be half into the random variable 200 minus 0 square plus half into the random variable minus 200 minus 0 square. So, this turns out to be equal to just 200 square. Now, you see that d u d w or u prime of w, this is 1 over w, and u double prime of w is equal to minus 1 over w square. So, therefore, the Pratt-Arrow risk premium is phi of w z tilde is going to be half sigma z square into 1 over w, and this is going to be half into 200 square into 1 over the initial wealth level 1000, and this turns out to be 20. Now, this risk premium calculated this way, this is slightly different from the Markowitz measure, that means the example A that we did in the previous lecture of risk premium of 20.20. So, you please see example A of the previous lecture. Now, this difference of 20 and 20.20 may be attributed to the errors that creeps in because of Taylor series approximation. So, this is some sort of a truncation error. Okay, now, the term So, we refer back to the Pratt-Arrow risk premium. So, the term in the bracket of the RHS is individual specific, and is referred to as the investor's measure of absolute risk aversion, or ARA, which is defined as capital A of W is equal to minus U double prime of W over U prime of W. All right. So, just recall that we had these two terms here. This is going to be half sigma square term and this term which involves the utility. So, this term here is investor specific and this term is independent of the investor, since it pertains to the specific risky investment that is being offered to the investor. Okay, so, now we have defined what is the absolute risk aversion. Okay, since U prime of W is greater than 0 and U double prime of W less than 0. So, I am talking from the point of view of a risk averse investor. So, therefore, we have A of W is greater than 0. So, now I will make a couple of observations, and it is the following. The size of the risk premium phi W Z tilde is, as I have already pointed out, determined by the product of two terms. The first one is that the variance of the payoff Z tilde, and so that means it is the sigma Z square term, and the absolute risk aversion. Okay, so a greater risk premium is required as the payoff becomes more and more volatile. That means, as sigma Z square becomes higher and higher, a greater risk premium is required, and as the investors' absolute risk aversion increases. So, this statement follows immediately from the fact that the risk premium phi W tilde can be decomposed into two quantities, namely the variance of the payoff Z tilde, which is denoted by sigma Z square, and the absolute risk aversion. So, this risk premium has to be higher under two circumstances. The first circumstances is when this variance increases. So, this means that the payoff becomes more and more volatile. So, resulting in sigma Z square increasing, and consequently the risk premium increases. The other scenario is that if the absolute risk aversion increases, all right, which is this case, then also it will result in an immediate increase of risk premium. So, the increase in risk premium typically can then be attributed these two factors, which is why we have identified these two factors here. Okay, so the absolute risk aversion A of W is a measure of how the investor's preference for risk changes with a change in the wealth. So, if an investor wants to put more wealth in absolute currency, or sometimes it is called the absolute dollar amount, in risky investment, as her or his wealth increases, it is said that the investor exhibits decreasing absolute risk aversion. So, this means that as the investor gets richer, she or he becomes less risk averse. Okay, so, this concludes our discussion on absolute risk aversion, and now we move on to the next concept called the relative risk aversion. We start off by observing that this is another method of analysis would be to look at the risk premium expressed as a proportion P of the wealth. So, this is accomplished by redefining phi of W z tilde is equal to P of W. So, the reason why you are doing this, basically we want to see the risk premium as a proportion P of the wealth level. So, we also accordingly by the same motivation express the random payoff as, what is the random payoff? It was z tilde, and we express this as r tilde of W. So, again we just express this as a proportion r tilde of the wealth level W, where r tilde is the rate of return and E of r tilde. So, obviously, E of r tilde will be given as E of z tilde over the wealth W. Since E of z tilde is 0, so this is going to be equal to 0. This represents a fair investment. So, as a result, what you can say? So, as a result, we start off by recalling the statement that E of utility of W plus z tilde, this is U of W minus phi of W z tilde, and what we are going to do is we are going to rewrite this as this can be rewritten as expected utility of W plus r tilde of W equal to U of W minus P of W. So, we have got this r tilde of W from here, and we have got this P of W from here. So, we now take the same approach as before. So, taking a Taylor series expansion of u of w r tilde of w. So, again I look at this component here about r tilde of w, we obtain u of w plus r tilde of w is going to be u of w plus r tilde of w into u prime of w plus 1 over 2 factorial r tilde of w square u double prime of w plus order of r tilde w cube. So, as before, this is the remainder which we ignore, and this is approximately 0. So, this expression is approximately u of w plus r tilde of w u prime of w plus 1 over 2 factorial r tilde of w square u double prime of w. So, this means that if I take the expectation on both the sides, it will be the expected value of this u of w plus r tilde of w is approximately u of w. Remember, this expectation is 0 and I am left with the third term, that is half u double prime of w, w square, and r tilde is square will be simply sigma r square. So, let me call this relation 3. Okay. So, we now also take the Taylor series expansion of u of w minus p w. So, this term on the right hand side about p w. So, we get u of w minus p w, this is going to be u of w minus p w into u prime of w plus order of p w square. And this is the remainder which I ignore. So, these are the quadratic terms onwards. So, this is approximately 0. So, accordingly this I will get as u of w minus p w into u prime of w. So, I call this relation 4. So, now since these two terms are identical, so this means that this term and this term is identical. So, I can equate the right hand side of 3 and 4. So, equating 3 and 4, we obtain u of w plus half u double prime of w, w square sigma r square. This is going to be u of w minus p w into u prime of w. So, therefore, p which is a function of w and r tilde. So, it is this p. This is going to be equal to, so these two terms will cancel out. So, I will get half sigma r square, then you will have u double prime of w by u prime of w from here, and I will have a w term here, okay, and then I will have minus of this. So, therefore, the proportional size of the risk premium is a function. So, this proportional size here means p is a function of the initial wealth, that means p is a function of the initial wealth w here, and of course, these two terms involving initial wealth and this term. So, accordingly we write, and the variance of the rate of return. The term in the bracket on the RHS, that means this term here is individual specific, because it depends on the wealth level W and the utility of the individual, and is accordingly referred to as the investor's measure of relative risk aversion, RRA, which is defined as R of W is W into AW, which is minus W of U double prime of W divided by U prime of W. Now, this relative risk aversion RRA is going to be positive for rational investors, because U double prime is negative and U prime is positive. So, for rational investors, so accordingly this is positive for rational investors who want more instead of less and are risk averse. So, we can say that the proportional size of the risk premium, that means P, is determined by the product of two terms. So, the first one is the sigma r square. So, this is the variance of returns from the risky investment, and secondly the measure of the relative risk aversion. Okay, so, the final punch line on this, so I will say that R of W, which you would recall is defined by W into AW, is a measure of how the percentage of wealth invested in risky assets changes with a change in wealth. So, if the investor increases or equivalently decreases the percentage of wealth invested or in a risky investment, as her or his wealth increases, then the investor is exhibiting. So, in case of increases, the wealth, the investor is exhibiting decreasing RRA, and in case the investor decreases the percentage of wealth in risky investment, then it means that the investor is increasing their relative risk aversion. So, we come to the last topic of this lecture. This is on measuring risk aversion. So, I will just state some assumptions related to risk aversion. So, 4 assumptions consistent with rational investment behavior. The first one is investor would prefer more to less. So, that is u prime of w is greater than 0, which you have already seen. Now, investors are typically risk averse. So, this means that u double prime of w is going to be less than 0. Thirdly, investors exhibit decreasing absolute risk aversion, that is a prime of w is less than 0, and finally, investors exhibit constant relative risk aversion, that is r prime of w is equal to 0. So, these 4 properties, the first one is the that is a utility function is an increasing function. For a risk averse investor, u double prime is less than 0, and the third and fourth property pertain to the absolute risk aversion and relative risk aversion behavior in case of a rational investor. Okay, so now what we do is we look at a few examples of utilities. So, let us look at some utility functions u of w along with what is the restriction, what is going to be the u prime of w and u double prime of w, what is a of w and a prime of w, and r of w and r prime of w. So, this will be some sort of a ready reckoner which you might need to refer to again and again. Okay, so, let us look at the first one. The first one that we will consider, this is going to be the quadratic utility given by b of w minus c w square. The restriction on the constants b and c are that b is greater than 0, c is greater than 0, and w is less than or equal to b over twice c. The u prime of w, as you can easily see, is b minus twice c w. So, since this needs to be positive, that is how you have got this condition here, and u double prime of w is minus 2 c, right. So, that is how we got the condition c is positive, and consequently b is also going to be positive. The a of w in this case is going to be twice c over b minus twice c w, and so this a prime is going to, a prime of w is going to be positive, and r of w is twice c w over b minus twice c w, and this is also going to be positive. Okay, the next one that you look at, this is exponential. So, in this case, the exponential function is given by minus e raised to minus c w, and the restriction is c is positive. So, the u prime for this is going to be c e minus c w. So, since I need this to be positive, so obviously that is why I have this condition. The u double prime is going to be minus c square e raised to minus c w. So, this, as you can see, is going to be negative. A of w is going to be c, and so a prime of w is going to be 0, and the relative risk aversion is c w, in which case it is going to be r prime is going to be positive. Okay, the third one, this is a very important utility function, log of utility functions. So, ln of w. So, there is no restriction, I mean where wealth is anyway positive. So, I do not consider that as a separate restriction. So, here u prime of w is 1 over w and u double prime of w is minus 1 over w square. A of w is 1 over w. So, a prime of w is going to be negative and r prime of w is 1. So, this means that r prime of w is going to be 0. And finally, we come to what is known as the power utility, and you look at two forms of this. We can either have w of raised to 1 minus gamma, and the restriction being gamma between 0 and 1, or we can have minus w raised to minus gamma, which means gamma is going to be positive. So, u prime of w in the first case is going to be 1 minus gamma into w raised to minus gamma, and u double prime is going to be minus gamma into 1 minus gamma w raised to minus gamma minus 1, and here it is going to be a gamma w raised to minus gamma minus 1 and minus gamma into gamma plus 1 w raised to gamma minus gamma minus 2. So, here that since I need this to be positive, that is the reason why I need this condition, and from here also I can account for this condition, and from here and here we observe that this condition has to be positive. Okay, so, here a of w in the first case is going to be gamma over w, and in the second case is going to be 1 plus gamma over w, and in both the cases the a prime of w is negative and r of w is simply going to be gamma and 1 plus gamma, in which case r prime of w is going to be 0 in the first case and also 0 in the second case. Alright, so this concludes our lecture for today. So, just to make a summary of what we have done, we picked up two important concepts today extending the utility theory. One is which is known as the absolute risk aversion and other is the relative risk aversion, and we defined both of this in terms of getting the risk premium. So, in the first case, in case of absolute risk aversion and in the second case of relative risk aversion, we got that these quantities are going to be a product of the volatility of the risky associated with the risky investment, which is some sort of a generic phenomena that is applicable to all investors who are going to be offered this fair risky investment, and fair in the sense that the expected value of the returns is going to be equal to 0, and in case of and the second component which involves the utility functions as well as the wealth level is something that is individual specific. And we looked at some of the interpretation of both absolute and relative risk aversion, and looked with an emphasis on the scenario when the investors are rational, in which case this means that they are going to be risk averse. And then we concluded by introducing some of the commonly used utility functions, namely quadratic, exponential, log and power utility. We looked at what the restrictions are. We looked at the u prime, u double prime, a of w, that is absolute risk aversion, and r of w, which is the relative risk aversion, and to ascertain whether they satisfies the four properties enumerated in terms of the rational investment behavior. Remember that preceding these examples, we enumerated four properties, that is u prime of w greater than 0, u double prime of w is less than 0, and two properties pertaining to absolute risk aversion and relative risk aversion. So, this concludes our preliminary discussions on utility theory, and from the next class onwards, we will start looking at the usage of utility theory in the paradigm of portfolio analysis. Thank you for watching.